Today, we will show you how to use the circuit breaker tester JYK-II. First, the tester must be taken out of its case for testing. This helps ensure effective heat dissipation during operation. First, plug in the power cord, connect the contact gap test leads. We are demonstrating the VS1 vacuum circuit breaker. Its upper terminals A, B, and C correspond to the yellow, green, and red test leads, respectively. The lower terminals are short-circuited using the black shorting leads supplied with the tester. One black LED is connected to the tester. For this type of 3-contact gap vacuum breaker, we must ensure that one side is used for signal acquisition and the other side is shorted. Never short both sides simultaneously. Now, connect the contact gap leads to the JYK-II tester. The black lead is the common terminal. Since the common terminal of the first two ports, A1, B1, C1, is connected to the grounding stud, so we only need to connect to the first port. Now, connect the ground wire of the tester to ground. The contact gap leads are now fully connected. Next, connect the closing, opening control leads and the stored energy, spring-charged, leads. The closing, opening control leads are now connected to the breaker's terminals. Refer to the wiring diagram for the breaker. The green lead is for opening, the black LED is common, and the red LED is for closing. Now connect the stored energy spring-charged leads. Red is for closing, black is for opening. Since the DC power supply inside the tester and the interlock power supply are the same source, the polarity must not be reversed. Otherwise, it will cause a short circuit and damage the power supply. Always carefully check the wiring diagram. This breaker does not have an interlock power supply, so we will not connect interlock leads. Next, securely connect the travel sensor. The moving contact of the sensor is connected to the moving contact of the breaker. We choose a linear sensor. Use the fixed bracket to mount it, and connect the sensor cable to the tester. Now insert the sensor cable into the tester's port. All wiring is not complete. Turn on the power. The tester operates on 220 to 240 volt AC. These two buttons adjust the LCD contrast. Press any button to display the main menu. View, Test, Settings, File, and Save. We will first enter test settings, which include test set, voltage set, time set, power operation, state, energy store, and speed definition. Go into test set. Here is trigger with options: intro trigger, external trigger, sensor trigger, manual trigger, and current trigger. For today's test, we choose intro trigger, internal trigger, DC power output from the tester to operate the breaker. External trigger means the breaker is operated by an external power source. For example, if you choose external trigger, save the setting, and return to auto test. The tester will remain in standby without outputting power until an external trigger voltage signal is received at this port. Only then will it operate. When internal trigger is selected, the external trigger test leads must not be connected. Now, set it back to intro trigger. Set the time step. For a single open, single close operation, 250 milliseconds is enough. For reclosing, select 500 or 1000 milliseconds. The default sensor is channel A. Sensor types include linear and rotation. We will choose linear. If we want to test stroke, turn on stroke test and select open. When this is on, the stroke set specifies the sensor travel. Note: if set to off, the stroke set defines the breaker's total travel. We now select stroke test gives open. The linear sensor has a travel of 50 mm, so we set it to 50 mm. Speed set is set to a close before open sequence of 6 mm. This is the breaker speed setting. For an SF6 breaker, we can choose the IEC standard of 10 milliseconds for the close before open sequence. Here, we are using 6 mm. This is the line number setting. Combinations of 26 letters and numbers can be used to label the test results for saving. These are the closing and opening coefficients for breakers from certain manufacturers or special designs with a linear scaling factor. We can adjust the coefficient accordingly. Changing the coefficient multiplies the measured speed. For example, if the speed is 1.0 and you change the coefficient to 0.9, the speed becomes 0.9. This applies to both closing and opening. After all settings are complete, save them, then go to voltage set. For example, if the breaker coil is rated at 220 volts, set it to 220 volts. The left key decreases voltage, the right key increases it. The up, down keys fine-tune, left, right keys coarse-tune. Once adjusted, press OK to save. Normally, the set voltage matches the actual coil voltage, with less than 1 volt difference. Then go to Energy Store. The JYK-II can charge the stored energy mechanism of 110 volts and 220 volts breaker coils. Other voltages are not recommended for charging, because the tester's power supply is designed for short-term operation, mainly for closing, opening. Using it for charging at other voltages may damage the power supply. Because the vacuum breaker's charging current is relatively small, stored energy charging is not a problem. Press OK to start charging. The display will show a prompt, and once you press OK, the DC power supply outputs. Left, right keys are for coarse adjustment, up, down keys for fine adjustment. The display will show energy storage is on, and you can see the breaker's motor charging the spring mechanism. When charging is complete, the screen will display a prompt. Press OK to turn off the power output. Note: before this step, do not directly press reset or ESC if the relay has not opened. A sudden press could cause reverse voltage, potentially damaging the tester. Always follow the on-screen prompt. First turn off the power, then press ESC to exit. Now that charging is complete, we can proceed to the test stage. If you choose auto test, the tester will determine whether to perform a closing or opening operation based on the status of the first port, A1, B1, C1. You can also manually choose open test or close test. Since we are connected to the first port, we can choose auto test. Press OK and all the previously set parameters and modes are ready. The breaker is currently in the open position. Press OK again, and the breaker will operate. After closing, the timing per break timing, coil current curve, and other measurements are displayed. Press the down key to view other data, including opening time, pole synchronism, contact bounce time, speed, over travel, and more. Because the tested breaker is old, you can see variations in over travel. We will now demonstrate printing a single page. The display prompts press OK to print. If we select Print All, it will print all test data, including curves. Returning to the results page, we see the closing time for phases A, B, and C. Pole synchronism is 1.0 milliseconds, contact bounce time for phase A is 0 milliseconds, B is 1.69 ms, C is 0.41 milliseconds. Bounce speed, phase A, 0.66 meters per second, B, 0.66 meters per second, C, 0.66 meters per second. Since only phase A had a travel sensor, speeds for B and C are calculated. Over travel, phase A is measured, B and C are calculated. Maximum speed, coil current, over travel, overshoot, and total travel 15.0 mm are also displayed. The above is the closing test for the JYK-II. Opening tests follow the same procedure. Choose Open Test manually. Press OK to perform the opening test. The opening test shows signals, coil current, travel curves, opening time, opening speed, opening gap, maximum opening speed, coil current, and coil resistance. This was a single open, single close test. Now we will perform a reclosing test. For reclosing, first charge the stored energy mechanism. Go to the storage control interface, press OK. The breaker begins charging, display energy storage is on. Once charging is complete, press OK to turn off the power, then press ESC to exit. If the breaker is open, we can only perform a seal close open test. From the earlier measurements, the maximum closing time was 50.24 milliseconds, so the reclosing time interval must be at least 10 milliseconds longer than that. We will select 60 milliseconds. Press OK and the breaker will perform the close-open operation, close then open. The reclosing time, H1 first closing time, F1 first opening time, dead time, closing speed, opening speed, and coil current are displayed. If you want to save the results, go to the File menu and choose Save File. The results will be stored even if the tester is powered off. Now the breaker is open and no energy remains to perform a closing operation. If you want to close it again, you must recharge the stored energy mechanism. Charging complete. Now we will perform an OCO open-close open test. First, the breaker must be closed, which requires another stored energy charging cycle, then proceed with the OCO test. For OCO, the first interval is 300 ms, and the second interval must be at least 10 milliseconds longer than the measured closing time. Since our closing time is 50.24 milliseconds, we set the second interval to 60 milliseconds. When we press OK, the tester displays a message saying the set interval is incorrect, because 300 milliseconds plus 60 ms equals 360 milliseconds, which exceeds our current time step setting of 250 milliseconds. Therefore, we must go back into settings and change the time step to 500 milliseconds. After returning and saving, we repeat the OCO test. When we press OK, the breaker performs the OCO operation. Open gives close gives open. The travel curve for each operation is displayed, along with coil current. Test results include first opening time F1, first closing time H1, second opening time F2, metal short time, the brief metallic short circuit duration between close and open, dead time, no current time, closing speed, first close, opening speed, first open, closing speed, second close, coil current. Next, let's explain how to set manual speed. First, go into Test Set and find Speed Set. Select Manual Speed and save. Then go back into Test Set and open Speed Def. The first setting is the closing start point, contact separation point for closing, which defaults to 0 millisecond. This can be set to a specific time before closing. For example, set it to 10 milliseconds if you want to measure speed starting 10 ms before contact touch point. Similarly, the opening start point, contact separation point for opening, is 0 milliseconds by default. This can also be set to a specific time, for example, 10 milliseconds after separation. These settings can also be defined in terms of distance in millimeters rather than time. For example, starting speed measurement 30 millimeters before contact touch point, or 50 millimeters after contact separation point. Press Save to store the settings. The tester will then use these definitions for speed measurement. In summary, when testing on-site, the two most important precautions are: 1. Always ensure proper grounding. 2. For closing, opening leads, stored energy leads, and interlock power leads, never reverse polarity, as this can cause damage.